So, on the last session, we were doing parallel lines, right? I'm going to do a revision a bit. I'll speak about what I spoke about. I don't think I have to write it down. I said that parallel lines are lines that have the same orientation and never meet, right?
Yes.
And I defined the transversal as I said the transversal is a line that intersects two or more lines. They don't have to be parallel. If you have a transversal that intersects two or more lines, if you have a line that intersects two or more lines, call it transversal. Then I also spoke about corresponding angles between parallel lines and the transversal. I defined corresponding angles are the angles that are sitting in the same positions in relation to the transversal and the lines. Are you clear with that?
Yes.
And then I said, I defined an axiom. I think this axiom, I should put it down. So I said, if you have two parallel lines like this, right? This is A, this angle, or this is B, the line AB, C, D. If these two lines are parallel and they're intersected by the transversal EF, right?
Yes.
I said the corresponding angles are
Equal.
corresponding angles are equal. So if two parallel lines, right,
Yes.
are intersected by what? By a transversal. Then their corresponding angles are equal. I said this one here, it is an axiom, right?
Yes.
I said an axiom is a statement or proposition that is straightforward, that is clear, you don't need to prove it. Are you with me?
Yes.
And also, I also gave the converse of this. What is a converse? A converse is the reverse of the statement that you have. It's more like you're going in the opposite directions. So here I gave you two parallel lines. Those two parallel lines are intersected by a transversal. Then I said corresponding angles are equal. A converse is going in the other direction now. So it's more like I'm going to give you corresponding angles, which means you have parallel lines. So to do that, I'll say if you have two lines, did I say they are parallel?
No.
You have two lines, and those lines are intersected by a transversal, such that the corresponding angles are equal. That's why I'm giving you the corresponding angles that being equal. Then those two lines are what? Are parallel. So a converse is a reverse of the statement that you did. Are you with me?
Yes.
So I'm saying here, I gave you two parallel lines that are intersected by the transversal EF. I told you the alternate angles the corresponding angles will be equal. What are corresponding angles? I said corresponding angles are angles that are sitting in the same position related to the line and the transversal. For example, see this part here is the same as this one, because it's on the right hand side of the transversal and below the line. Right hand side of the transversal, below the line. Is that clear?
Yes.
If I were to point other, say this one here is the same as that one here, because it's above the parallel line and on the left hand side of the transversal, above the parallel line, left hand side of the transversal. So if you speak about alternate corresponding angles, are the angles that are sitting in the same position relative to the transversal and your line. Those are your corresponding angles. Are you with me?
Yes.
Okay. So now, I said now, if you have two parallel lines and they're intersected by a transversal, then the alternate angles or the corresponding angles will be equal. Are you with me?
Yes.
Now, I'm going to write the converse. This is an axiom. You don't have to prove this. It's straightforward.
Yes.
Because I said the other day that if these lines are parallel, it's more like they're copy and paste of each other.
Yes.
If they're intersected by EF will intersect them in the exact same way, because it's like you're intersecting the same line twice. Are you happy?
Yes.
Okay. Now, the opposite, I'm going to give you equal corresponding angles. Right?
Yes.
Then, from that, it's clear that your lines will be parallel, but I'll speak more about that. So, on the reverse, this is what I give you. I'm giving you these lines, EF, right? And GH, maybe. And these two lines are intersected by transversal AB, maybe. Can you see?
Yes.
And I'm telling you that this angle here is equal to that angle there. It could be any angle. It could be this one equal to that. Could be this equal to this, or this equal to this one. It doesn't have to be this one. As long as you can see that two corresponding angles, which is angles that are sitting in the same positions being equal. It's the same situation. So in this case, I'm saying if two lines are intersected, are you with me?
Yes.
By a what? By a transversal. Right?
Yes.
Which is, you can see the intersection happening there.
Yes.
Such that the corresponding angles are what? Are equal. So, I'm saying to you, if you intersect two lines by a transversal so that the corresponding angles are equal, then those two lines are parallel. Are you with me?
Yes.
Then, the two lines are what?
Parallel.
Are parallel. Which means they have the same orientation. Because if you intersect them at the same angle, which means they should be sitting in the exact same way.
Yes.
Because if both intersect them at that angle K, which means both of them are exactly the same way, so that this line intersect them in identical manner, in an identical manner. Are you happy with that?
Yes.
No problem. So these are axioms. This is your axiom and this is converse. You don't need to prove it. So I want to define a few other angles and then we can continue going forward. So I'll define a few more angles on parallel lines. Are you with me?
Yes.
So this is what we did last time. So I'm done with the recap. I'll continue now. So let me continue with the same ink, blue. So let's suppose that you have these lines here. This line and that line. Let's say this is AB, C, D, and intersected by this line, which is what? EF. Are you with me?
Yes.
I'm telling you that these two are parallel, which they have the same orientation. Are you with me?
Yes.
So this is A, B, C, D, E, F, G, and H. So if you have two parallel lines that are intersected by a transversal, what do you know for sure at this point?
Corresponding angles are equal.
The corresponding angles are equal. Which is, can you tell me any corresponding angles that you can see here?
Yes.
Tell me.
A and E.
A and E, others?
B and F.
B and F,
C and G.
C and G, yes?
D and H.
Yes, because they are sitting in the same position in relative to the transversal and the lines. Are you happy?
Yes.
Okay. Then now I want to define other angles. I'll first define what? Interior angles. Angles on parallel lines. Are you with me?
Yes.
So, what are interior angles on parallel lines? What does interior mean?
Inside.
Inside. So, if you're defining interior angles on parallel lines, those are angles that are inside the parallel lines, which is that between the parallel lines. Can you see? So, interior angles are angles in between the parallel lines, are those that are between the parallel lines. So interior angle on parallel lines are angles, right?
Yes.
That are what? That are in between what? Parallel lines. Can you see the parallel lines there?
Sorry.
Can you see your parallel lines there?
Yes.
Which ones?
Parallel lines. It's A and B.
It's A, B,
C, D.
C, D.
Yes.
So can you see the angles that are between those parallel lines?
Yes.
What are they?
It's C, D. It's angle C
Angle C,
and angle D.
angle D. Is that all?
No. Angle E
Angle E
and angle F.
and angle F. So these are called interior angles. Are you with me?
Yes.
And then you can have exterior angles. These are angles that are outside your parallel lines, which is those that are outside. You can see the betweens are here,
Yes.
the outside are elsewhere. So I'll define exterior angles on parallel lines. Are you with me?
Yes.
What are they? Are angles that are outside the parallel lines. Can you see them?
Yes.
What are they?
Angle A, angle B,
Angle A, angle B,
angle G,
Angle
and
G.
angle H.
and H. Are you with me?
Yes.
Those are called what? Exterior angles. Are you clear so far?
Yes.
Then I'll go on and say alternate angles. Alternate angles. Are you with me?
Yes.
Are you with me?
Yes.
I'm defining what? Alternate angles. So I'll define alternate angles as angles are interior angles first. Are you with me?
Alternate angles
Uh-huh.
into the angles.
Yes.
Okay.
That are non-adjacent
Okay.
and are on opposite side of the transversal. Which means it's two interior angles that are not adjacent and they are on the opposite side of the transversal. Does that make sense?
Can you repeat?
I'm saying alternate angles are interior angles.
Okay.
So it's one of these four.
Yes.
They are non-adjacent, which is they're not sitting next to each other. And they're on opposite sides of the transversal. For example, if you look at C, so D is excluded already
Yes.
as a what? As an alternate angle for C.
Yes.
This because it's adjacent.
Yes.
And this one is also excluded. Why? Because it's on the same side of the transversal.
Yes.
So it should be this one, F.
Oh, okay. I get it.
So alternate angles are interior angles, which is there between the parallel lines.
Okay.
Are you with me?
Yes.
And those interior angles, they're non-adjacent and they're on the opposite side of the transversal.
Okay.
So alternate angles are non-adjacent, which is they're not next to each other. A non-adjacent angle, non-adjacent interior angles, right? That are on opposite side of the transversal. Is it clear?
Yes.
So alternate angles are non-adjacent interior angles that are on opposite side of the transversal. It's a pair. It's a pair of non-adjacent, which is two non-adjacent angles. So it's this and this and this and that. So some people, they say they form a Z like this. can see the corners of Z, or maybe like this. That's what is it? If you look at it, so you can see there's some sort of Z there.
Yes.
But now the angles for Z are not acute angles anymore. So they say they form this one, the Z like this. And your alternate angle, your corresponding angles, they say they form an F if you look at it. You can see it's either there, here, or there, or here, or up there. Are you with me?
Yes.
Or this F can be backwards like this. Which means now if you're looking at it, here is it. So is Z alternate angles, is an F your things, corresponding angles. Then I'm going to define the last ones, last type of angle. These angles are called core-interior angles. Core-interior angles. Do you know what these are? Yeah. Let me define them. Core-interior angles are non-adjacent interior angles that are on the same side of the transversal. So for example here, the example of here, alternate angle here, is what and what? Your alternate angle is C and what? Angle C and?
Alternative angle.
The alternate angle here, alternate angles here. C goes with what?
With F.
With angle F. And your D goes with what?
C goes with F. And D goes with G.
But G is an exterior
No.
angle.
D goes with E.
Goes with E. That's it. So, I said core-interior angles are non-adjacent angles, right? That lie on the same side of the transversal. Can you see them?
You said non-adjacent angles.
Are non-adjacent interior angles that lie on the same side of the transversal. Can you point for me? Which angles do you think are interior angles here?
Interior angles. It's C.
Is C?
And D.
No.
Interior.
No. Co-interior angles. Do you understand the definition first? I'm saying co-interior angles is a pair, which is two non-adjacent angles that lie on the same side of the transversal. Do you understand that, what that means?
Okay. Yes.
So tell me which two angles are in co-interior angles there?
It's C
And what?
and E.
Yes, because they are both interior and they're on the same side of the transversal. What others?
It's D
And
F.
That's it. Those are your co-interior angles. Co-interior angles are non-adjacent angles that lie on the same side of the transversal. Then, let's go. So, co-interior angles are non-adjacent, right?
Yes.
Interior angles, which is between parallel lines, that lie on the same side of the transversal. For example, what are they?
C
C
and E.
and E, because they are not, C and E are not C and E are not adjacent, right?
Yes.
But they lie on the same side, which is what we want. So the alternate angles are non-adjacent but lie on opposite side of the transversal. What other pair?
Angle D
D
and angle F.
and angle F. Is it difficult?
No.
So those are the angles that I want to know. All of them, all of the angles that I've had so far. I don't think I'm going to define any sort of angles. Are you happy so far?
Yes.
Okay, can I clean the board?
Yes.
Okay, so now we're going to continue with these lines. The same lines that I just defined. Alternate angle and co-interior. Those are the only ones that I just defined, right?
Yes.
I'm just going to talk about those. Okay. So, I said, if you have two lines, right?
Yes.
Right. If you have two lines, say A, B, and C, D. Are you with me?
Yes.
Both intersect them with this thing. So you have A, B, C, D, E, F, G, and H. Are you with me? So let's call the transversal EF. So you have two parallel lines AB and CD, both intersected by a transversal. Right?
Yes.
So I define alternate angles and co-interior angles. I define corresponding angles, alternate angles, and co-interior angles. Right?
Yes.
So what I'm going to do now, I'm going to tell you more information about those angles. So the first one, I'm going to say, if you have two parallel lines, right,
Yes.
that are intersected by a transversal, your alternate angles are equal, will be equal. Which means your C is equal to angle F, and your D is equal to angle E. If the lines are parallel. Are you with me?
Yes.
Let me state that. So this is a theorem, right? So theorem, let me just say theorem alternate. Just going to name it this. You do not need to know this theorem. I just want you to know the end result of it. Which is, if you see two parallel lines intersected by a transversal, you should know corresponding angles will be equal. And now your alternate angles will be equal. So I just want to show you why. Are you with me?
Yes.
No problem. So I'm saying if two parallel lines are what? Are intersected by a what? By a transversal. Then your alternate angles are equal. Are you with me? I'm saying if two parallel lines are intersected by a transversal, then alternate angles are equal. Are you with me?
Yes.
So the first part before the then is what you are told to do. They're saying take two parallel lines and intersect them with a transversal. If you do that, they're telling you now, this after then is what is the claim, is what you should be willing to prove. Are you with me?
Yes.
Are you with me?
Yes.
Okay. Then, now, on this case, our claim is what we want to prove, which is this thing under, after then. So, do you want us to use this diagram?
Yes, we can use.
Because I don't want to redraw it. Are you with me? So, I'll say now the claim, which is what you want to prove. Because it's important to identify the claim so that you know what you're doing. So the claim is that alternate angles are equal, right? What are our alternate angles there? What are our alternate angles there?
It's C
Angle C?
and angle E.
No, those are co-interiors. Because they are co-interiors, they're on the same side of the transversal. They are non-adjacent angles that are on the same side of the transversal. Alternate angles are, they form a Z, are the non-adjacent interior angles that are on opposite sides of the transversal.
Okay, so it's C
Angle C
and angle F.
and angle F. Those ones are equal. That's a claim. What is another claim?
Okay, we said C and F,
Mm-hmm.
right?
Mm-hmm.
Then it's gonna be D
Angle D
and angle E.
and angle E. Because they are interior angles that are opposite, that are non-adjacent interior angles that are on opposite side of the transversal. So, what I want to do now, want to prove that, right? Let's go and prove this now, because we want to prove our claim. Once we do that, we're done. Are you with me?
Yes.
Okay. The first thing that I'm going to do, saying proof now, right? Because that's what we're going to do. We're going to prove. So, I'm going to say my angle C, right, is equal to angle B. Why? Angle C is equal to angle B. Why are they equal?
They are vertical opposite.
They are vertical, opposite angles. Are you with me?
Yes.
Now, I'm going to say my angle B is equal to angle F. Why?
Angle B.
Angle B is equal to angle F. Why are they equal?
Alternative angles.
No, that's what we're trying to prove. You can't use that because it's what we're trying to prove. What other relations between B and F? What kind of angles did I tell you so far?
It's alternative angles and co-interior angles
Mhm.
and corresponding angles.
What are corresponding angles?
Are the angles that are sitting on the same position.
Look at A and B and F. Are they not corresponding?
Yes.
Because they're both, you have parallel lines. You have two parallel lines. You have a transversal. That's a perfect condition. So these two are equal. You need to be able to identify those. Don't just think about those that you did. Think about everything so far that I've done. Okay. So angle B is equal to angle F. Why?
Because
Angle B is equal to angle F. Why? Again, what is the relationship between F and B?
F and B,
Mm.
those are the angles that are sitting on the same position.
What are they called?
Corresponding angles.
That's why they're equal. They are corresponding angles on parallel lines. So you say B is equal to F. Why? They are corresponding angles. But not all corresponding angles are equal because they're sitting in the same position. They're only equal there because the lines are parallel. So you need to say that what? Your AB is parallel to CD. You need to study these things and know them, because it seems like you're struggling with corresponding angles, and that's not a good sign. Okay. So look now. Your angle C is called your angle B. And your angle B is called what? What does it say about these two?
Angle C is equal to angle F.
Yes. Because if your angle B is equal to, and if your angle C is equal to angle B, and the same angle B is equal to F, then C is equal to F. So, therefore, angle C is equal to angle F. Look. Which is the first claim that we said here. Is it difficult? And you need to know, like, you don't need to know the proof, but what if you can know them, it will make things easier. Because you'll be able to see these things. So, let's go to the second one. D and E. There is D. I'm trying to prove that this is equal to this. I'm going to use the same trick. Are you with me?
Yes.
Going to say, okay, we're done with the first part. Want to prove this one. I'm going to say my angle D is equal to my angle A. Why? Angle D is equal to angle A. Why are they equal? These are vertically opposite angles. Are you happy?
Yes.
Then, the same angle A is equal to angle E. Why? They are corresponding angles. They are sitting in relatively the same positions. So, A is equal to angle E. Why? They are corresponding angles. You need to mention that the lines are parallel. Because they are equal because the lines are parallel. So, say your AB is parallel to what? To CD. Is it clear?
Yes.
Look now, your D is equal to A, and your A is equal to E. What does it say about D and E? They are equal. Because if you are the same age as me, and I'm same age as Uzi, the notion is now you're also the same age as Uzi. Therefore, your D is equal to your E, which is the second plane. So, from now going forward, if you see two parallel lines intersected by a transversal, your corresponding angles are equal and your alternate angles are equal. I'm not sure if that makes sense. Are you with me?
Yes.
Going forward, if you see two parallel lines intersected by a transversal, you should know that your corresponding angles are equal and your alternate angles are equal. Are you following?
Yes.
Okay. So now, if you remember, when I was still doing the alternate angles, there was the corresponding angles. There was a converse there. I said that if two lines are parallel and they are intersected by a transversal, their corresponding angles are equal. And then I turn around and say that if you have two corresponding angles, right,
Yes.
then the two lines are parallel. Do you remember that?
Yes.
Same thing here as well. Here, I'm telling you that if you have two parallel lines that are intersected by a transversal, your alternate angles are going to be equal. I'm turning around, I'm saying, if you have now two alternate, if you see two lines that are intersected by a transversal, such that your alternate angles are equal, just know those two lines are parallel. So the converse is also true here as well. What are you trying to write this?
No.
Oh, it's okay, no problem. So we need to prove now the theorem alternate converse, which is the converse of this, which is the other direction. So in that case, I'm saying to you, we're done with this. So what I'm trying to say now, I'm saying I'm going to prove theorem alternate converse, which is the reverse direction of our theorem. Are you with me? I'm saying if two lines, I'm not saying they're parallel now, are intersected by what? By a transversal. Such that, or so that, the alternate angles are equal. Are equal. Are you with me? Then the two lines are what? Are parallel. Are you with me? So now I can't use that diagram because that diagram you had your alternates and stuff. I'm going to draw another one here where there will be no parallel lines. So A, B, C, D, right? And they are intersected by EF. Can you see here?
Yes.
So you have A, you have a B, you have A, you have B, you have your C, D, E, F, G, and H. Are you following?
Yes.
So I'm telling you that if your alternate angles are equal, right?
Yes.
Then the lines are what?
A
Are parallel. Look. So what we are given here. So what we want to prove? What we want to prove, ne? Right, to prove. What we're going to prove. Okay, or let's say our claim. No, just claim so that I can be consistent. So the claim is that AB is parallel to what? To CD. This is what I'm trying to prove. Because I'm given two lines that are intersected by a transversal. And I'm told that this angle is equal to this, and this is equal to that. Are you with me?
Yes.
So let's go with the proof. So I'll say proof. What are we given? We're given that your angle C is equal to angle what? Angle F. And we given this one. Are you with me?
Yes.
And angle E is equal to what? Angle D. This is also given information. Because they said that if two lines are intersected by a transversal so that the alternate angles are equal, that's what you're given. Then the two lines will be parallel. That's what you want to prove. That's your claim. Are you with me? No problem. So we want to show that these two lines are parallel. Look now. My angle C there. Can you see angle C?
Yes.
Is equal to angle B. Why? Vertically opposite angles. So those two lines are equal. Those two angles are equal. Are you with me?
Yes.
At the same time, look. At the same time, your angle C is equal to angle F. Because that was given information. Because C and F are alternate angles. So your angle C is equal to angle F. This is given information. I'm not sure if you see what I'm trying to say.
Yes.
Angle C is equal to B. Those are vertically opposite angles. And your angle C is equal to angle F because that's what you're given. Therefore, what can you conclude? Can say that our C is equal to F because they are both equal to the same thing. Therefore, C is equal to what? Angle F. Can you see that? No. B is equal to angle F. Because you have C equal to B and your C equal to F, which is these two are also equal.
Yes.
So your B is equal to F. Are you with me?
Yes.
Now, I need you to go and look at B and F. What is the relationship between B and F?
B
And F?
are corresponding angles.
They are corresponding angles. If you have two corresponding angles that are equal, what does that tell you?
If I have two corresponding angles.
Yeah, look, you're saying B and F are corresponding angles,
Yes.
right?
Yes.
Which they're sitting in the same position. But we just prove that these two angles, these two corresponding angles are equal.
Yes.
What information does that tell you about the lines?
They are parallel.
That's what we're trying to prove. Therefore, AB is parallel to what? To CD. What is the reason? Because our corresponding angles are what? Are equal. That's it. This is what we wanted to prove. Is it difficult?
No.
So, what I'm saying to you now, the take home to this, is that if you have two parallel lines that are intersected by the transversal, the alternate angles are equal, the corresponding angles are equal. If you have two parallel lines intersected if you have two lines now intersected by a transversal, such that the corresponding angles are equal, those two lines are what? Are parallel. If you have two lines intersected by a transversal, such that your alternate angles are equal, those two lines are what? Are parallel, which is what we just proved. I have two more proofs to prove on these things. Then we can do some exercises. Are you happy so far?
Yes.
I'm going to clear the board now. I'm done talking about I spoke about corresponding angles and alternate angles. Now I'm going to speak about co-interior angles and then we do some problems. Are you ready?
Yes.
Okay. So I'm going to have a similar scenario. This is A, B, C, D. Can you see? E, F. Are you with me? Are you with me?
Yes.
So, I define, let's put them, A, B, C, D, E, F, G, and H. So I define corresponding angles are angles that are sitting in the same position in relation to the transversal and the lines, right? I defined the alternate angles as non-adjacent interior angles that are on opposite sides of the transversal. It's a pair of non-adjacent interior angles that are sitting on opposite sides of the transversal. I define co-interior angles as non-adjacent, as a pair of non-adjacent interior angles that are on the same side of the transversal, which is E and F, D, or E, so C and E, D and F. Those are your co-interior angles. Are you with me?
Yes.
Okay. So what you need to know at this point is that this theorem here that I'm going to do. If you have two parallel lines, right?
Yes.
And your two parallel lines are intersected by a transversal, your co-interior angles are supplementary. Do you know what supplementary means?
No.
It means they add up to a total of 180. Because if you add your co-interior angles, they will add up to 180. Supplementary means add up to 180 degrees. For example, what is the sum of angles in a straight line?
It's 180.
Adjacent angles on a straight line, they add up to 180. They are said to be supplementary. Angles on a straight line are supplementary, which they add up to 180. That's what supplementary means. Do you understand?
Yes.
So, I'm saying now, say theorem co-interior. I'm just going to name them these things. Are you with me?
Yes.
If two parallel lines are intersected by what? By a transversal. Are you with me?
Yes.
Then co-interior angles. Co-interior angles are what? Are supplementary. What does supplementary mean?
Means that the sum of those angles are add up to 180.
Yeah, the sum of those angles is 108. What is the sum of angles in a triangle?
It's 180.
Which means they are?
Supplementary.
Yes, that's what supplementary means. Which means if you add those angles, they add up to what?
180.
So I'm saying if you have two parallel lines, and those two parallel lines are intersected by what? By a transversal, then the co-interior angles are supplementary. So my claim here, which is what I want to prove, my claim is that my E plus angle what?
C.
Is equal to
180.
degrees, and D
And F.
and F is equal to?
180.
That's what I want to prove. That is my claim. Are you with me?
Yes.
Okay. So, how do we do this? We say, okay. So So I want to prove that the sum of these two is 180, right?
Yes.
Okay. How can we do this? We can say, okay, angle, proof. We can say, if we add C, angle C, right?
Yes.
Plus angle A, what do they give us?
Angle C.
Plus angle A,
180.
they give us 180 degrees. Why?
Angles on a straight line.
These are angles on a straight line. Are you with me?
Yes.
Are you sure?
Yes.
Okay. Then we added these two angles, right?
Yes.
Fine. Then what happens if we add these two? What do we get?
180.
Angle, or actually, so we added these two, right?
Yes.
So what we should be doing, let's add these two and see what will happen. So angle E plus angle G, what do we get?
180.
Why?
Angles on a straight line.
These are angles. These are angles on a straight line. Are you with me?
Yes.
Okay. Look now. We're trying to prove that if we add this and that, what do we get? We get 180. Actually, I just saw something. I think we're going to run into problems. I think we're going to run into problems. Okay. Here's what I'm going to do. Okay, so we said C plus A, what did they give us?
180.
They gave us 180 degrees, right? Yes. Fine. Look now. I'm going to say now, I'm trying to put E, I'm trying to get E involved. Look now. Our angle A is equal to angle D. Do we agree?
Yes.
Why?
These are vertical.
These are vertically opposite angles. Are you with me?
Yes.
I can say my angle D is equal to angle H. Do you agree?
Yes.
Why?
These are the corresponding angles.
Corresponding angles. Do I just write this?
No.
What else do I write?
I will say AB.
AB is parallel to CD. Are you with me?
Yes.
What if I say now my angle H is equal to angle E? Would you agree?
Yes.
Why?
Vertical opposite angles.
These are vertically opposite angles. Look now, your A is equal to D, your D is equal to H, your H is equal to E. What does it say about E and H? Your E and A? Therefore, your E is equal to your angle A. Do you know? Do you see why?
Yes.
Because if A is equal to B, D, and D is equal to H, and your H is equal to E, which is A is equal to E. Instead of having A, then we can just put the E and say that our C plus A, which is equal to what? E, is equal to what? 180 degrees, which is our claim. Are you happy?
Yes.
So, we can tick it off. We're done with this one. Go to prove the second one. It's going to be a similar method. So, what do we say on the second one? Trying to prove D and F, right?
Yes.
No problem. Let's take that part there and say angle D plus angle B. What do we get? 180 degrees. Why?
Angles are straight.
Those are angles on a straight line. Are you with me? So what are we trying to put in? We're trying to get F involved. Can you see?
Yes.
Okay. So how do we get F involved? Because we would like to say D plus F is called 180 degrees. So at this point, we added these two.
Yes.
Are you with me?
Yes.
Okay. So we're going to follow a similar logic as we did in the previous thingy, which is the one that we were dealing with. Are you with me?
Yes.
So let's follow the B that we're trying to get rid of. So your B is equal to C.
Yes.
Your C is equal to G.
Yes.
And your G is equal to what? That's it. Can you see?
Yes.
Let's write it down. What are we saying? I think our B is equal to
C.
angle C. Why?
Vertical operator.
These are vertically up angles, right?
Yes.
And then we say our C is equal to what?
G.
G. Why?
Another corresponding.
These are corresponding angles. Because AB is parallel to CD. And then our G is equal to what? To angle F. Why? These are vertically opposite angles. Are you with me? Therefore, from this, it's clear that your your B is equal to what? Your B is equal to F. Because B is equal to C, C is equal to G, G is equal to F. Therefore, your B is equal to F. Angle B is equal to angle F. Are you with me? Which now implies that your D plus B, instead of having what? Or instead of having that B there, we can have what? An F instead. So D plus B, but our B is F, is equal to 180 degrees, which is our second claim. We're done here. Are you with me? So if you see any co-interior angles, they will add up to 180 degrees. Are you with me? Are you with me? No problem. Because if you think about this, there's this shape that you like the most, this one. What is this shape called? Parallelogram. These two, can you see that these are co-interior angles because they're between parallel lines?
Yes.
So they're supplementary. And so are these ones here, because they're still between two parallel lines still. So don't just look at them on just these two intersecting lines. Even the shapes that you like, they do exhibit these properties. So if you see any two parallel lines that are intersected by transversal, corresponding angles are equal, alternate angles are equal, co-interior angles are supplementary. Are you with me? Now I'm going to do the last one, which is the converse of this. I don't want to know the proofs, I just want you to know the logic behind it. I just want you to know the results, which is these things that I'm proving. So, what am I saying? So, I'm saying now, if two lines, are they parallel? I didn't say that. If two lines are intersected by a transversal such that the core interior angles are supplementary. Are you with me? So I'm giving you two lines to be intersected. I'm allowing two lines to be intersected by a transversal so that the co-interior angles are supplementary. Then the two lines are what? parallel. So it's the converse of what we just proved. Are you with me?
Yes.
So, in that case, you have this line here, AB maybe, and this line here, CD. And these two are intersected by a transversal. You have A, B, C, D, E, F, G, H. Such that the co-interior angles are supplementary. So what you're given is that C plus E is called 180, D plus what is called 180, D plus F is called 180. If you see that, then know the lines are parallel. Are you with me?
Yes.
Then, so, claim. What is the claim here? Do you know what the claim is here? What do you want to prove? If two lines are intersected by a transversal such that the co-interior angles are supplementary, then the two lines are parallel. What are we claiming here? A claim is what we're trying to prove. What are we trying to prove?
We're trying to prove that angle C and angle, when you add angle C and angle E, you will get 180.
No, but you're not trying to prove that. You are told that. It's the first part. Look, before then, I told you this before. What is before then is what you are given. What is after then is what you are trying to prove. What is after then?
The two lines are parallel.
That's what we're trying to prove. All the time. Look at this. What is this? What is?
Co-interior angles are supplementary.
Look at me clearly. What is behind the then is the claim, is what you're trying to prove. What is in front of the then is what you are given. So they've given you two lines that are intersected by transversal. And yeah, that's it. And then they give you two parallel lines intersected by transversal. Those is what I've drawn there. Look here. Here I'm just given two lines. Are they parallel? No. I just drew these blank lines here. So what am I trying to prove here on this case, on this diagram?
Well, I prove that AB is parallel to CD.
That's a claim. That is a claim. That's how to identify. That's how to know what you want to prove. Look before then. That's what given information, which might be useful or you expected to use. After then is what you're supposed to prove. Is what after then is what you're supposed to prove. Because the first part is the condition, and the last part is an assertion. So it's their claim. So they're saying is going to happen. Okay, so then now proof. Are you with me? Are you with me? So what I'm given that E, because they said the co-interior angles are supplementary. It's before then, so that's my given. So E plus C is equal to 180 degrees, and D plus F is equal to 180 degrees. I'm not sure if you see what is here. Okay. So this is my given information. You can say given. Are you with me?
Yes.
Okay. So from this point, we said this and this is equal to, we said this and this, wait, we said C plus E is equal to 180 degrees, and D plus F is equal to 180 degrees. So what we're trying to prove, we're trying to prove that these two lines are parallel. So how are we going to do that? So here's what I'm going to propose. Do you see the D here?
Yes.
This D is equal to H.
Yes.
Do you agree?
Yes.
D is equal to H. Oh, actually, no, we can't say that. Because no one said these lines are parallel.
Okay.
I'm not sure if you hear what I'm trying to say.
Yes.
Did anyone say these lines are parallel?
No.
No one did. Fine. We can't say that because we can't say they're equal because they're not, no one said they are parallel. So we said E plus C is equal to 180 degrees, right? What is C plus A?
That's 180 degrees.
So you can say, okay, A plus C is equal to what?
80 degrees.
180 degrees. Why?
Angles on a straight line.
These are angles on a
Straight line.
straight line. How is this 180 compared to this 180?
The same.
So if these two are equal, so is the left hand side. Which means your E plus C of the top one is equal to A plus C. So this and that go away. You're left with E to be equal to what? A. Where is E and A? Here is E and here is A. What are these angles called? If the corresponding angles are equal, what does that mean?
The lines are parallel.
That's what we're trying to prove. This one almost gave me a beating. I was not sure how to do it. So your AB is parallel to what? Your CD. Why? Because the corresponding angles are equal. That's it. So to summarize this, if you're given two parallel lines intersected by a transversal, the corresponding angles, the alternate angles, the co-interior angles, huh? The co-interior angles,
Interior.
These ones.
Co-interior angles are equal.
I even just told you, I just told you about the parallelogram right now.
Oh, sorry. Co-interior angles are supplementary.
So let me restart. If you are given two parallel lines that are intersected by a transversal, what do you know?
Corresponding angles are equal.
Corresponding angles are equal, yes.
And co-interior angles are supplementary.
Co-interior angles are supplementary. What else?
Well, corresponding angles are equal.
Corresponding angles are equal. But you are repeating that. And alternate angles are equal. So alternate angles are equal, corresponding angles are equal, co-interior angles are supplementary. So now, on the other side, if you are given two lines that intersect such that the corresponding angles are equal, those two lines are parallel. If you are given two lines that are intersected by a transversal such that the corresponding angles are equal, then those two lines are parallel.
Yes.
If you are given two lines that are intersected by a transversal such that the alternate angles are equal, then those two angles, those two lines are parallel.
Yes.
If you are given two lines such that the co-interior angles are supplementary, then those two angles are what? Those two lines are parallel. So the way of proving two lines that are parallel show that the corresponding angles are equal, or alternate angles are equal, or co-interior angles are supplementary. Those are the ways. Those are the three ways you can show that two lines are parallel. What do? You show the corresponding angles are equal if you can. If you cannot, show that alternate angles are equal. If you cannot, show that the co-interior angles are supplementary. That's how to show that two lines are parallel. Do you want me to write that down?
No.
Do you hear it?
Yes.
So I'm going to do a few exercises around this, and then you'll do the rest on your own time, because I do have a lot of them there so that you can be familiar with this. So I'll clean the board and then you do it. Any questions?